Hello, everyone, and welcome to another fine edition of Stat 140. We are just about done with hypothesis testing. I think we might even be done. We are in the end of week 11. This is, I think, the 20th lecture, I believe. And as usual, I'll be putting them up on my YouTube channel. Please like and subscribe. And we are preparing for the exam next week. And we have been working on confidence intervals, and we have been working on hypothesis testing, right? These are the two wonderful things, confidence intervals and hypothesis testing. And you have 8 situations for confidence intervals and 8 situations for hypothesis testing. Thank you, I'm getting a lot better. And for those situations, I wrote out the confidence intervals. I definitely wrote them all out, all of them. I know that for a fact. And for hypothesis testing, I think I did. I don't remember where we left off, to be honest. So let's see if I can see a page and say, oh, yeah, we did that. I think, well, let's see, the homework that's up should be up to 20, I think. So let's quickly go through 21. Yeah, I think that's what we're up to. I think we're up to 21. So we're going to do 21 and we're going to do 22 today. And then we're going to finish. So let's look at chapter 21. Okay, so chapter 25, phase Berkowitz. What the hell does that mean? You guys are talking nonsense again. What's phase Berkowitz? Was that like my screen name or something? Like, hey, your phase. Yeah. Okay. So comparing two means. So we know that when you have one mean, we want it to be an SRS, and it has to be from a normal distribution. Well, when you have two means, it has to be from two SRSs, and they have to be two normal distributions. Right? That has not changed. It's basically the same idea. Okay. So the difference is that both of them have to be SRSs, and both of them have to be normal. And we also want them to be independent. That means they don't have any effect on each other, okay? And when it comes to actual tests, that's really what you're gonna have. You're gonna have situations of independence, so you don't really have to worry about that. But you can very well have a question that says something along the lines of, what are the conditions necessary for me to use this test? And those conditions are on page 465, if you have the book. You should have the book. This will be the 2 sample t-test that we're getting to, yes. Okay. The reason why it's the 2 sample t-test is because we do not know the sigmas for the 2 populations. Remember, we use Z when we know the sigmas, and we use T when we don't know the sigmas. This applies to 1 sample. This applies to 2 samples. This applies to confidence intervals. This applies to hypothesis testing. It makes no difference. Okay. But on page 465 are all these little details, like they have to be SRSs and they have to be normal. And you want the sample sizes to be large enough. So you should read that on page 465. Page 465. I assume you all have access to the book in that regard. But at the end of the day, what we care about is the formula. And the formula is, for the confidence interval, we already know this is for the hypothesis testing, it's as follows. First of all, what are we testing for when we're dealing with 2 means? We are testing for whether or not mu1 is equal to mu2. Okay, we are testing for whether or not the 2 sample means are equal. Okay, if the 2 sample means are equal, then we want to accept the null hypothesis, or at least not reject it. What are the 3 possible alternatives to the sample means being equal? If the sample means are not equal, then we have 3 options, as we've always had 3 options: greater than, less than, or not equal to either mu1 is greater than mu2, mu1 is less than mu2, or mu1 is not equal to mu2. Now, even though these are all 100% correct, we can think of it in a slightly different way. We can think of it in a slightly different way, which is not mu1 equals mu2, but rather mu1 minus mu2 is equal to 0. And that's a slightly better way to think about it. Mu1 minus mu2 is equal to 0. So what are the three alternatives for mu1 minus mu2 not equal to 0? It's either mu1 minus mu2 greater than 0, mu1 minus mu2 less than 0, or mu1 minus mu2 not equal to 0. So rather than looking at them as comparisons of to each other, mu1 and mu2 in comparison, what we do instead is we compare them to the number 0. It makes it a little easier conceptually to think about it. Because then if I look at my bell curves for the 3 situation, for mu1 minus mu2 greater than 0, where do I land so that I will reject the null hypothesis? Where do I have to land if I'm dealing with mu1 minus mu2 greater than 0 to reject the far right? Excellent, to the far right. And for mu1 minus mu2 less than 0, where do I land so that I'm going to reject the null hypothesis? Far left. And for mu1 minus mu2 not equal to 0, then it's going to be on both sides. Notice how the ideas are the same for all these different hypothesis tests, right? They're all the same. What we need, of course, is the test statistic. We need the number that we calculate, and then we compute the probability of being past it, because that's the p-value, the probability of being past that value. So the question becomes, what number do we calculate? And for this situation, it's as follows. T equals x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. Okay, this here is, hopefully you can see it, that is our test statistic. That's the one that our calculators, our computers, and for those who are fortunate enough in life to have Crunchit use, that's not Nutira, but it's a lot of other people. This is the formula that we calculate for our t statistic, and that's the value that we get and we plot on our bell curve. We put that on our bell curve and we say, okay, here's where here's where I landed. What's the probability of being past that? Because the probability of being past that is the p-value. Your calculators do it automatically, your computers do it automatically, Crunchit does it automatically, but you have to do it by hand if you don't have any of those. But that's what you do. You put in the data, you get your test statistic, and then you calculate whether or not you are past that, okay? The same way we do all the other hypothesis testing. And that's it for chapter 21. Okay, this is why I prefer, when I do these concepts of confidence interval and hypothesis testing, to lump them differently than the book does, because I kind of feel that the way I do it, you can just knock out all the hypothesis testing very quickly because they're all really the same. So you see if you, yes, so that, well, no. Your t statistic is what you got. That's your actual value. When you draw your bell curves, zeros in the middle, 1 to the right, 2, 3, -1, -2, and so on, you see what your t value is, okay? So if I get, let's say, 1.3, I go to my bell curve and I plot 1.3, which is 1.3 deviations to the right. Then I calculate the p-value, and that's the probability of being past that, okay? If I pass the p-value, that's, if that value for passing the p-value is small, I reject the null hypothesis. That means there was a very small chance of me getting that far out. And I did get that far out. Well, if there's a really small chance of it happening, and yet it happened, I don't know. I'm thinking the null hypothesis might not be right. Because if the null hypothesis was right, that really just, it shouldn't have happened. It's too unlikely of an event. So what's my conclusion? Either I got really, really, really unlucky, or the null hypothesis was wrong. Which one of those is the more likely conclusion? Well, that's the whole idea, okay? Is it more likely the null hypothesis is wrong, or that I got really, really, really unlucky? It's more likely the null hypothesis was wrong, which is why in that situation, that's when I will reject the null hypothesis. Yeah, no, refreshing your brain is always good. I have no problems with people refreshing their brain. So you find the t-value and then calculate what you calculate the likelihood of being past the t-value. Not the t-value, you keep using that word. It's the t statistic. which is what t is equal to in this formula. You calculate what t is equal to, and then you calculate the likelihood of being past that value. If that likelihood is small, that means I was way out there, and chances are, if I'm way out there, chances are that the null hypothesis was wrong in the first place. And if the null hypothesis was wrong in the first place, let's reject it. But if there's a high likelihood of being out there, then why would I reject the null hypothesis? Lots of things land out there. Does that make sense? Maybe a little more, a little, I hope so, a little bit. No one's saying anything, we'll assume yes. Okay, so that was chapter 21. Okay, so at this point, we are done with all confidence intervals and all hypothesis testing. Which is really, you find t-stat and then calculate t-value. Now, I don't know what this t-value is. There's no such thing as a t-value. Stop using that word. Okay, what is a t-value? It's nothing. You calculate the p-value. Ah, that's what you heard t-value, even when I said p. I'm sorry. P is in pterodactyl. I apologize. Okay. What? Is there a problem there? Would you have preferred I said P is in pneumonia? Or P is in psychotic? Or P is in phosphorus? Or P is in
Paraguay.
No, that actually sounds like the letter P. That doesn't work. The whole point is not to sound like the you just missed the whole point of that. It's okay.
When I'm playing a game.
Huh? What was that? You're playing what? What the hell is that? Pfeffernussen? That's not even a word. Okay. Now you're just making things up. Now you're just making things up. Pfeffernussen. Is that real? I don't know. Okay, anyways, at this point, we have all the confidence intervals done and we have all the hypothesis testing done. Chapter 21 is finished. Now we get to chapter 22. But I think we covered chapter 22, to be honest. Chapter 22 is about type 1 and type 2 errors. Did we cover that, or do you like a refresher on that if you don't remember?
A little refresher.
A little refresher is never a bad idea. Okay. Okay. So let's make a little table here. And this table will have, if you mean Pfeffer, it's a cookie. How do I not know about this? Is that like a snickerdoodle? But that's not spelled the same way. Anyways, so there's two options. So we have a chart here. We have a 4-square table. On the very top of the first column, write H naught is true. And the other one, write H naught is false. Right? So our two headings are the null hypothesis is true and the null hypothesis is false. Okay. To the left, we're going to write reject the null hypothesis or not reject the null hypothesis. Reject the null hypothesis or not reject the null hypothesis. Okay, now, two of these boxes represent actions on your part that were good, that were correct. Which two of these boxes, or at least give me one of them at a time, give me one box of these 4 boxes that represents the confluence of two statements that together are valid. Nobody says anything, I'm going to fall asleep. So someone has to say something. All right, are you all with me on this one? Are we all on the same page? Yes, no, maybe so. Anyone? What's the sides again? Either reject the null hypothesis or do not reject the null hypothesis. Sort of confused on what we're doing. Well, we made this table. That's what we're doing. Did you make this table? This is chapter 22. Did you make this table? Yes. Okay. So 2 columns, either the null hypothesis is true or the null hypothesis is false, and then 2 rows. Either we reject the null hypothesis or we don't reject the null hypothesis. 2 of those boxes are good things. We did the right move. Which 2 of those boxes are the right move?
Would it be null hypothesis is true and we don't reject the null hypothesis?
Well, if the null hypothesis is true, we don't want to reject the null hypothesis, right? It's true. So if we do not reject the null hypothesis, we are happy. We made a good move. This is the limit of my artistic ability. So if you're better at drawing faces than I am, which I highly doubt, because this one is, I mean, it's like a Van Gogh. Although he's missing both ears, not just one. That's ironic. But anyways, so that's a good move. And then there was the other one, which Mariah said was the top right, which is rejecting. Did no one get my ear joke? Seriously? Not a single smile or a laugh? Oh, you guys are uncultured. Anyways, the other one is rejecting the null hypothesis when the null hypothesis is false, right? If the null hypothesis is not true, we would like to reject the null hypothesis. And that's, again, a good decision on our part. So we are happy there as well. Good job, us. Now, if the null hypothesis is true, do you want to reject it? No. So if you do so, you made an error. And we call that a type 1 error. A type 1 error is rejecting the null hypothesis when the null hypothesis is true. Of course, you'll never truly know if you made a type 1 error because you'll never truly know if the null hypothesis is true. But you know who does know if the null hypothesis is true? No, even Crutcher doesn't know. I was going to say that. Oh, I like to use a Roman numeral 1. That's what the book uses. The book uses the Roman numeral 1, page 498. I like to use a Roman numeral 1. So, the only one who knows is the man upstairs, the great turtle in the sky, assuming you believe in that kind of thing. Okay, if you don't, then I guess nobody knows. So, you make a type 1 error. What are you coming out for? You already made me dinner. Get back in your room. So, wow, okay, that's kind of weird. I had tuna for dinner, not tuna fish. I had actual tuna. A friend of mine caught a tuna that was like half her size, and she gave me a slab. So I had real tuna. Well, yeah, I guess it is tuna fish, but it's not like, the tuna fish that you get in the can, the chicken of the sea tuna fish. It's like tuna that was a fish, but it's not tuna fish. It's different. What did I eat today? Let's see. I had a shake, chocolate shake, and I had oatmeal, and I had my tuna and my cucumber, and then I had some cereal type thing that they give me. Well, this thing only has chocolate, vanilla, and strawberry, and I ordered the chocolate and the strawberry the first time around, and the chocolate is gross, but the strawberry is gross, but the chocolate's really good. Diet going good, 23.5 pounds as of this morning. No, the oatmeal sucked. The oatmeal sucked. I gotta admit, the oatmeal was bad. Thank you. Don't tell anyone, but I had some liposuction done. That made it go really, really faster. Anyways, Mo cheat day. No, my cheat day is gonna be November 15th because my birthday was like last week or 2 weeks ago or something, whatever it was. So my friends are taking me to Fogo de Chao on November 15th. And I'm already planning. I'm already preparing by having nothing to eat. Fogo de Chao. You don't know Fogo de Chao? Oh, what is wrong with this world? Something like the greatest restaurant in Los Angeles. Fogo de Chao, baby. Fogo de Chao. You live right there. Which one, on La Cienega? Well, that's awesome. Yes, we should all go. We should all go together and have like a class out. I've never even heard of. Oh, I'll tell you guys. I'm telling you that is. Oh. It's on La Cienega, south of.
It's next to the Beverly Center, right?
Yeah, it's south of the Beverly Center, or is it north of the Beverly Center? Maybe it's north. I don't know. It's right around there. It's right around there. It's. Let's see. I used to come down Laurel Canyon, and then I would turn onto the Fountain, and I'd come over to. I'll go to La Cienega, and I'm coming down La Cienega, and I would hit Beverly Center, and then my favorite Chinese place, but they went out of business more. And then I would keep going. No, it's south of Beverly Center. Yeah, definitely south of Beverly Center. And yeah, that's good Chinese food too. Anyways, guys, you got me monologuing again. Okay, so the other example is this one, where the null hypothesis is false, but you didn't reject it. You should have, but you didn't. So that's another error. What do you think that kind of error is called? Hey, can't get anything by her. Type 2 error. Oh, she used a regular. She did tip 2. Interesting. Tip 2. What does that mean? Tip 2. I don't know. But it's a type 2 error is correct. So we have type 1 error and type 2 error. Now, the probability of making a type 1 error, the likelihood of making a type 1 error, which means the likelihood of rejecting the null hypothesis when the null hypothesis is true. Well, let's think about that. $4 signs. $4 signs. What's $4? Oh yeah, it's expensive. It's it'll be, I don't know, about for dinner, it'll go about being $90 plus tax and tip and stuff like that. Yeah, that's why you go during lunch. It's like $45 or something like that. Tips of the trade. Yeah, that's what I'm talking about. Anyways, I ever tell you my story of Fogo de Chao? Did I tell you my story? I must have told you my story. I didn't tell you my story of Fogo de Chao? Okay, you want to tell you?
I think you should tell us.
Okay, so here's what happened. You guys got me off on a tangent again, but it's about me, so I love it. Okay, here's what happened. So I love Fogo de Chao. And I used to go there every Friday for lunch for about 2 years. No, not 2 years. That's nonsense. For like a year. I would go every Friday for lunch. And I would always sit at the same table in the corner. I'd bring my work. I'd have the outlets and I'd do homework and I'd eat and I'd put on a lot of weight. It was always awesome. And I'd always leave and I'd say, why do I do this to myself? I'm never coming back. And then the next week I would come back again because the food is so good. Now, then, you know how sometimes you do something a lot and a lot and a lot, and then you just kind of stop doing it, and you kind of like just stop and just don't do it for a while. Oh, the cheese bread, the cheese bread! I love the cheese bread. Oh my god, I can go just for the cheese bread, and the plantains or whatever those bananas are called. They are amazing. Anyways, I'm talking. So I don't go for like 2 years. I just stopped going, and then years go by. And then one day I'm driving by and I pass Fogo de Chao and I'm like, oh, Fogo de Chao. Oh my God, I love Fogo de Chao. I got to go in there and eat. I like impulse, like you just have to have it right then and there. So I drive in, I park, I walk into Fogo. The maitre d' walks up to me. He says, welcome back, sir. We have your usual table for you. Took me right to my corner table. Oh, what service. Isn't that beautiful? Isn't that beautiful? Oh, Fogo. Oh, just beautiful stuff. Anyways, so back here. So the probability of making a type 1 error, the probability of rejecting the null hypothesis when the null hypothesis is true. Well, let's think about that. We know what this is. We know what this is. Yes, Fogo was amazing. We know what this is. Because think of the bell curve. Think of our test. Think of when we reject the null hypothesis, right? We reject the null hypothesis let's say it's greater than, for example. I mean, it could be any one of the three, but let's use this as an example. So we reject the null hypothesis when we are past a certain point, right? But what is that point? That's the cutoff point. If we're past the cutoff, we reject the null hypothesis, right? Well, I know the cutoff point. It's what I compare my p-value to. It's the significance level of the test. The significance level of the test, significance, I don't know how to spell it. Significance level of the test is the probability of making a type 1 error, and the symbol that we use for that is just alpha. So when we say alpha, that's the significance level of the test. That's the cutoff point. That's also the point at which, if we're that defines the probability of making a type 1 error. So what do you think? What symbol do you think we're going to use for making a type 2 error? We can use beta. Well, that's the weird word, or two words, but yes, it is beta, right? Beta is the probability of making a type 2 error. There's only one problem with this. You see, if the null hypothesis is true, then we know what the mean is, the p-value, p is, whatever the null hypothesis is about. We know the value. Let's say the null hypothesis is that mu is equal to 10. If the null hypothesis is not true, then what is mu equal to? Well, it's either greater than 10, less than 10, or not equal to 10, right? Well, that's a lot of options. There's infinitely many betas, one for each possible alternative. So in problems, you will usually see something along the lines of calculate beta for this specific alternative, because every alternative has their own beta, okay? And we're not going to do any math with calculating probabilities or calculating betas, because the math is just a little bit beyond the level of this course. Not too much, but why teach anything we don't need to know for the test, right? I mean, that's just, the student philosophy in life. So the probability of making a type 2 error is beta. The power of a test at a specific alternative is 1 minus beta. So the power of a test for a specific alternative is 1 minus beta. So yeah, so anytime they ask for the power of a test, you just say, well, what's beta? And then you find beta and you do 1 minus that. So let's do an example. Let's do an example. If you have the book, I'm looking at 22. I'm looking at page 495. I'll draw a picture of it just in case you don't have the book or you don't have it in front of you. But essentially what we have is the following. We have a null hypothesis where mu is equal to 0. You okay?
Yeah.
What do you need?
Huh? No, I'm just thinking.
Why would you be thinking?
I can't help it sometimes.
Oh, this is stupid. All right, the null hypothesis is that mu is equal to 0. And we're going to use a alternative hypothesis where mu is greater than 0. So we're dealing with a situation like this. Null hypothesis, mu equals 0. Alternative hypothesis, mu is greater than 0. In this example, we know sigma. Sigma is equal to 1. We take a sample of 10, n equals 10. And we use an alpha of 0.05. And the alternative mu is equal to 0.8. So in this example, here's all our information that we're given. All right, the null hypothesis is that mu is 0. The alternative is that mu is greater than 0. We know sigma is 1 from some outside information. We take a sample of size 10. We're going to use a significance level alpha of 0.05. And then our alternate, no, not H, no, HA is that mu is, this is page 494, 495, yeah. The alternative is that mu is greater than 0. Now, if the alternative is correct, there's lots of numbers greater than 0. So which one should we use? If it's greater than 0, if you're going to reject the null hypothesis, you're like, okay, it's greater than 0. Well, fantastic. What is it then? So when you reject it, you say, I'm going to take this as my alternative. So in this particular example, they're taking 0.8 to be their alternative. Okay. And okay, so basically, here's what we have, right? We have our bell curve. We have our bell curve. Now, because it's an alternative of mu greater than 0, then which side am I going to reject the null hypothesis on? The left side or the right side? The right side, okay? Where is my cutoff point such that if I land beyond it, I reject the null hypothesis? Even before I take my statistic, can I find the cutoff point? And the answer is yes, I can. Think about it. We're using an alpha of 5%. Well, 1 second, we're using an alpha of 5%, correct? That means we want the probability of being past our value to be 5%. So all I want is to figure out what value makes this shaded area 5%. Well, how do I find the z-score? Remember, we know sigma, so it's a z-score. How do I find the z-score that makes it a 5% chance of being past it? Where do I go to get that information? To find the z-score, which gives me a 5% chance of being past it. Alpha is 0.05, which is why we're looking for the z-score that gives us a 5% chance of being past it. How do I find that? And in case you were wondering, this is open to the entire class. So anyone is free to just jump in and just, share your thoughts before I fall asleep. No. The 5% is alpha. The 5% is the probability of rejecting the null hypothesis if the null hypothesis was true. If the null hypothesis is true, then the center of my distribution is at 0, because that's what the null hypothesis says. The center is at 0. I'm going to reject if I'm on the far right. So I want the likelihood of rejecting to be 5%. I'm curious what this number is so that the likelihood of being past it is 5. Because that's the probability of rejecting the null hypothesis when the null hypothesis is true. How do I find that number? How do I find that number? Anyone? Oh, I see. When I talk about food, you're all just contributing, and you're like, yeah, let's talk about this. Yeah, it's fire. But when I talk about math, everyone's like, I don't know. I don't want to do this thing. Anyone? Come on. Start calling it. Food is easier than math. Just saying. Just saying. Like, I just intuitively knew that's what you meant when you said JS. It's crazy. Yes, but food is easier than math. That's true. Because we eat food from day one, or even prior to day one. The p-value significance. No, well, the p-value significance is it lets us know what the cutoff point is. It lets us know whether or not we pass the cutoff or not. The p-value is 5%. So we're looking for the point at which is a 5% chance of being passed. I'll tell you what, I will tell it to you, and then you tell me how I got it. It is 1.645. It's a z-score of 1.645. Oh, that number rings a bell, doesn't it? It's a 95% thing. Yes. Well, it's actually the 90% thing. 90% in the middle. 5% in either wing. 5% in either wing. That's what I'm looking for. OMG. So 1.645 is the z-score cutoff. If my z statistic is past 1.645, not my raw data, but my z-score statistic is past 1.645, I would reject the null hypothesis. So alpha represents the probability of being past it, of being past 1.645. Why are their numbers so different? Alpha is the likelihood of passing 1.645. Yeah. So why is their number so different? Well, it's only conceptual anyway, so that's okay. All right, so now if mu, how do you get 1.645 again? Because 1.645 was one of our basic numbers. 90% in the middle for the confidence interval. The cutoffs are negative 1.645 and positive 1.645, which leaves 10% past them, 5% on this side, 5% on this side, 5% past 1.645. Now, if the mean is really 0.8, which is about halfway in between them, if the mean is really 0.8, then notice how the peak is shifted to the right. Right? The peak is shifted to the right. Agreed? And then if I look at that same cutoff point, what do you notice about the area to the right of it when I shift it over? Can't see it if anyone's typing. What do you notice about the area to the right of the same point when I shift it over? It got a lot bigger. Now, remember, if we go to the right of that point, that's the rejection region. So if mu is really 0.8, right? If mu is really 0.8, this is going to be where I reject it. Right? Now that's a lot of rejection. That's too much rejection. That would be making a type 2 error. That would be rejecting it when I don't want to, right? So that represents my beta. The original one represents my alpha, and the new one represents my beta. right? In the first case, alpha is rejecting it when you want to. In the second case, beta is rejecting it when you don't want to. That's too big of a region. Why is it so big of a region? Because my sample size is so small. Usually when small sample sizes is beta is going to be very big for alternatives. Okay, so the power is the likelihood. The power is the other part. The power is the likelihood of not rejecting it when you shouldn't. So the power is the left of that cutoff under the assumption of the new hypothesis. Whereas beta is still rejecting it. So beta is big. I mean, power is big too, but beta is significantly bigger than we would like. The only way to make alpha and beta both small, to make the probability of making a type 1 error and the probability of making a type 2 error small, the only way of doing this is by increasing the sample size. Because in general, when you make alpha bigger, beta gets smaller, which is good, but now alpha is bigger. So I want a smaller alpha, but now beta is bigger. What do? Lowering one raises the other. It's going to go back and forth. So the only way to get them both lower is by raising the sample size, which is why we raise the sample size. What do you need to know for the context of this class is just alpha is the probability of making a type 1 error. Beta is the probability of making a type 2 error. And the power is 1 minus beta. Okay, that's what you need from this chapter. Other than that, this chapter's got nothing for us. Nothing, I say, nothing. And we are ready for the test. The power will be the unshaded region. That's correct. That's the likelihood of not rejecting the null hypothesis when you shouldn't. Sorry, wait. I'm so sorry. I'm so sorry. Sorry. I flipped them. I don't know how that happened. I flipped them. I'm sorry. Take back everything that I said for the last few minutes. I'm sorry. Oh, that's horrible. Beta is the left and the power is the right. Remember, beta is making a mistake, right? What's the mistake if the null hypothesis is, oh, it's horrible. What's the mistake if the null hypothesis is wrong? The mistake is not rejecting it, right? The mistake would be not rejecting it if the null hypothesis is wrong. Well, we don't reject it to the right of the cutoff. This is where we don't reject it. But we want to reject it if the null hypothesis is wrong. So this is my beta. This is rejecting it like you're supposed to. That's a good thing. That's the power. So again, recap, because that was horrible of me. If the null hypothesis is true, and this is where I reject it, then that's the mistake region. I rejected it when I wasn't supposed to. And this area here is where I don't reject it. This is good. We're happy here. If the null hypothesis is false, then I would like to reject it. So the shaded region is the good region. That's where I made a good move because it's past the cutoff. That's the good move region. That's the power. The other side is not rejecting it, but I want to reject it. That's the mistake region. So this is the beta. So alpha, beta, power. If I make alpha smaller, that means I move this line over. If I move this line over and the line goes over, then what happens to beta? Beta gets bigger. If I want to make beta smaller, I got to move this line this way. But when I do that, alpha gets bigger. Did that make sense as opposed to the first way? Is anyone following? I hope people are following. I said it again. I hope my initial transgression. It doesn't screw anyone over. But again, just to be clear, for those who are going to watch this later, is that alpha, because it's a bad decision, beta, because it's a bad decision, power, 1 minus beta. Okay, so look that over again, please. Do the homework. That's going to be up. That's it for this chapter. That chapter is very small, just the ideas of beta and power, essentially. So we are done now with confidence intervals and hypothesis testing. So alpha is when you reject it when you don't want to. That's correct. Alpha, you reject it when you don't want to. Beta is when you don't reject it when you do want to. And the power is the flip side of beta. So what is left for us? So when I look at the table of contents, there are some things we have to do. Namely, chapter 6, chapter 11, and chapter 24. Let me check quickly something. I think those are the only 3 chapters we have left. In which case, I'm going to make an announcement that might make some of you happy. But don't guess or anything like that. Okay. So let me load this up. I'm going to my professor's page where I get the homeworks from. And give me a second. Oh, okay. Sorry. Is anyone else tired? It's me. Are we all tired in this weird world? Okay. So his homeworks. He has homeworks on 1 through 6, 8 to 9, 11, 15 through 22, and 24. So let's take a look at our homeworks. Let's see what we have so far. So I have here 1, 2, 3, 4, 5. So we still need 6. I see 8. So we still need 9. And I don't see 11. We still need that. I see 15, 16, 17, 18, 19, 20. So we need 21, 22, and we need 24. Okay, now 21 and 22 I'm going to put up today because that's stuff that we just did. That's the stuff that we just did. So that's easy. So that means we have 4 chapters to go. And yeah, I need a red bill. Yeah, 100%. So 4 chapters to go. And we have 2 next week, 2 the week after, 2 the week after, 2 the week after. That's 8 minus Thanksgiving is 7. 7 chapters. Sorry, 7 classes for 4 chapters. So here's what we're gonna do. Next week, Tuesday and Thursday, I will not be taking attendance in class. I will be coming to class. I will be here. Those 2 days will be for you guys to come and ask questions, do homework, or ask me for help on homework or things that you don't understand. Okay. There will not be anything new. This was next week. We're not going to learn anything new next week. We still have time to finish the 4 chapters. So I'm giving you, it'll be basically 2 class periods of Tuesday and Thursday of next week. Okay. That will be the, 2 days of class besides my office hours that nobody ever comes to. That will be my 2 days of class to just solidify understanding, ask questions, make sure you have things down, preparing for the test. The Tuesday before the test, we are going to move on because I can't take indefinite amount of time. We are going to move on. We have 4 chapters to go, 6, 9, 11, and 24. And that'll give us 5 days to do 4 chapters, which I think should be fine. So yeah, we'll take a week. We'll take a week to solidify, go over confidence intervals, go over hypothesis testing. You're not required to come to the class, but I will be there. And I would love it if you guys showed up just to hang, if nothing else, but to study. Because at the end of the semester, I'm going to get people who are going to ask me for a little boost to their grade. I get it every semester. And the first thing I do is I kind of say, okay, well, how hard did I see you work? So this is your opportunity to show me that you're willing to work. You come, you ask questions, you listen to other people's questions, you listen to my answers to those questions, you do your homework. You got to do your homework anyway, so do it in class and in there with me there to help. That's the plan. Sound good? So a week of no new information. And yeah, that'll be next week. That'll be next week. So I'm going to put up the 21 and 22 homeworks. And so you'll have that time. And the test will be next weekend. And it will cover all confidence interval chapters and all hypothesis testing chapters, all the way up to 22. That's 15 or 16 through 22, something like that. The test will be uploaded on the 14th. The 14th is, oh, wait, what's today? Today is the 5th, right? No, it'll be uploaded on the 12th, right? All right, on the 12th, Thursday night. Yeah, you'll have the weekend to do it, but I'll do it. I'll put it up Thursday night, and then you'll have a weekend, and then get it to me, as soon as you can, so I can procrastinate and grade it later. Study guide. I know I have it written down. Study guide. A study guide. I don't know what to do for a study guide. What am I supposed to do for a study guide? What do I do? Like, know this stuff? Know everything. What's a study guide supposed to be? I don't understand. Is it like questions? I mean, do the homework. That's your questions. What's a study guide? Formulas. So the formulas. Okay, I can do formulas. I guess all the formulas and when to and oh great. All the formulas and when to use it. So basically everything. Oh my God. How many things? Sample questions are gonna be in the test, but different numbers. That's not happening. That's not happening. That's never happening. Oh, formulas. Study guide can be like formulas. Okay. All right. I will go through the book, the chapters, and I will write down the formulas. And then I will put the page number there so you can, I will put where, okay, because some of those conditions are like long and I'm tired. Okay. But I will put all the formulas that you will need. And I will put page numbers where you can go and see where the conditions are. Okay. And the paper I wrote today going to be uploaded as well. Yeah, if I think about doing it, but I'll probably make a clean one anyway. All the formulas and all the, well, first of all, I held it up like 19 times. Watch the video. You can see it like a million times. But I'll put I'll make the formulas and shit like that and stuff and, make you all happy until you get to test and you realize that just having the formulas doesn't mean anything if you don't understand the formulas. So hopefully you will understand the formulas and then you will use them to great abandon and you will do fabulously. Okay. This has been a good talk. I feel really good right now. Wide awake, you can tell. I'm just raring to go. I just gotta make it for another 10 days before my Fogo outing. I think I'll manage. I think I'll do it. I think I'll do it. I got a new TV today. It's nice. Yeah. Here, I'll show you my new TV. I took a picture of this promo video on my new TV. So that's the picture that I took. You can't really tell looking, but like you could actually like see in windows and stuff. It's like 12K or something like that. Not sure I know what that means, but what is that? That's too many symbols. I don't know. Like I lost you like right in the center. Like eyebrows up. I think I caught that. Maybe shoulders, but all those like things at the end. I don't know. That's one in my car. Yeah. No, I didn't spend $12,000. That's not what I meant. No. 12K is like the number of pixels or something like that. You know, like 4K and yeah, not $12,000. That's crazy. I would never spend $12,000. I only spent like 9,000 or something. 12,000 is nuts. Who would do that? That's crazy. So 12,000. I'm just kidding. It was like 1,500 or something. Yeah, I know. It wasn't really 9K. I was just joking. It was nice. I needed it. Now, when I'm in class, I can pretend to talk to you guys when I'm really watching TV. It's really fantastic. You know, so I'll be like, that's interesting. Yeah. Well, yeah. Oh, yeah. That's good. That's good. Like watching like my, you know, right now I have a fjord, I think. It's a mountain. It's like water. You know, those like, screensavers, it keeps going different things. Like I saw the Milky Way earlier and it's, it's nice. It's let's see. This is my, that's what I have right now. That's my screensaver. So hold on. Maybe the light is coming up. No, that doesn't work either. Oh, well. Kind of hard to see, but oh yeah. I think it's on my chess set there. That's my chess set right there. What I do, I sit in front of the TV and I look. Oh, those are my books. Those are some of my books. Those are my other books. Those are some books, and those are my other books. And that's my chess sets. And this is my desk. And those are some more books. And that's my whiteboard. So checkers. I'll give you a house tour later. It's not really a big house. It's not really a big house, but yeah, it's nice. It's nice. Yeah, pays the bills. Yeah, I'll make a house tour video. Lifestyles of the non-rich and not famous. That's what it'll be. Actually, it's not a gated community, and I really wish now it would be after I got robbed a couple days ago. But other than that, it was. Did I tell you about this? These people or person, I don't know, person. My roommate comes upstairs. She's like, "Where's my PlayStation?" I'm like, "I don't know. It's your PlayStation." Oh, I told you about this? Yeah. So, I don't even remember what I told. I'm like my parents now. You know how like my parents will say the same stories to me over and over and over again because they don't realize how many times they've told me. That's kind of like how that's like I'm getting now. How was your casserole? Whose casserole? Huh? The desk. I didn't
Remember you were asking for desk like options where you should get a new desk?
I haven't bought it yet. I'm kind of cramped back here a little bit. I need a desk, but I haven't really found one that I'm not gonna get a standing desk. Are you crazy? I'm lazy and fat. I'm not gonna get a standing desk. I'd have to stand all the time. That would be horrible. No, I want to sit. I want to lean back. I want to relax. I was in a car accident. Yeah, I know how you. I'm sorry about that, but I know how you feel. But whose casserole? What was that about? What's a gaming car desk? Oh, Kahir. Oh, that makes more sense. Kahir. Oh, so you put a star in a misspelled word? That's like a faux pas if I've ever heard one. can't star. Now you got to put a double star for the next one. Now it's got to be a triple star because I can't even talk right now. My cousin does woodworking. Do you want me to ask if you will take a commission? Something tells me that will be even more expensive. I'm thinking that'll be more expensive. I don't know. I'll just keep looking. Like I'll know it when I see it. I don't have a lot of room this way. I have a little room this way. I want to get like either I want to get like a maybe like a U desk. Wooden or glass? Yeah, I was thinking of glass, but I'm so accident prone that I'd probably break it. So I was thinking of going wooden instead. Dump their desks. No, I want a new desk. I'm not going to buy an old desk and use desks. Who knows what people did to that? I can never do that. You know, I got to get a new one. It's got to be nice so I can ruin it. I mean, that's really what this is all about. Ruining my own stuff and not stuff that's already ruined from someone else. Because, yeah, you can't just get ruined stuff. How much room you got for the desk? I don't know. I would say maybe 8 feet wide and maybe 4 feet deep. I would say something along those lines would probably do it. Maybe 7 feet wide. I don't know. Yeah. Oh, it's nice. It's mountaintops now. It's very soothing. I need an L desk. I know I need an L desk. I need an L desk. I just can't find the one that I really like. It's like I need a certain depth to it because I want to be able to have my computer here and I want to be able to write. And right now, when I do it, as you can see, like, you know, when I write, it's like I have no room. Like the desk is like over. And I want one deeper. I want one Koreatown. Well, if I'm going to go to Koreatown, then I'm going to go to Sannangdan. That's my favorite restaurant down there. You guys familiar with Sannangdan? I'm sure I've talked about it because how can I not? It's like one of my favorite restaurants other than Fogo de Chao. Try Daikokua. Is that a restaurant or is that a
It's a ramen restaurant. They have like the best ramen.
Ramen. Isn't that like noodles and stuff?
Yes, kind of like pho, but better.
Oh, ramen. Little expensive. Dude, when it comes to food, there's no such thing as too expensive. You go where the food takes you. Tatsu, Gesundheit. Tatsu to you as well. Tatsu. Oh, that's a restaurant? Din Fai. What is that? Is that a word thing? I'm going to write these things down. Hold on. Din Fai Fang. I feel like it's like I smell the blood of an Englishman or something like that. Like, what's that something? Go to Jinya. Okay, Jinya. Okay. Din Tai Fun. People got that already. One. What else we got? Daikokua. Okay. Oh, I got some good choices here. Now, I'm on my diet right now, so I get one cheat meal a month. One time a month, I say, you know what? Shishingumi. All right. So, and better, Wancock. Keep coming, guys. Keep them coming. These are good things.
If you go to Daikokuya, I suggest the one in Little Tokyo because the other ones don't make it as good.
Little Tokyo?
Yeah, go to that one. Don't go to the West Hollywood one. Or there's like another one by UCLA as well.
Okay. All right. Anything good in the Valley? What the hell is this? 50. Oh, wow. Did you like just find that? And for 160? Large dimensions. What? Look at that. That was so quick. You got that like right away. It's crazy. Now, so the only question is, so the only thing I don't like about that, I like it. I do. I'm not saying I don't like it. I'm looking for something that's more, you know, what's the word I'm looking for? Like classy. You know, something for a nice office. Like I feel like for $160, something, well, it could be modern. I'm not necessarily commenting on the style, but that's like, you know, a tabletop type thing and a couple stands. You know, I want something, you know, that people look at the desk and say, nice desk. You know, I don't get a lot of, hey, nice blank. I don't get a lot of those. You know, maybe now I'll get, hey, nice TV. And I'll get, hey, nice, you know, I don't even know anymore, but well, for like $1,000, so link it, Betty, link it. Well, let's see what you got. Let's see. I don't know why I'm recording this. Like the last 20 minutes, we've done like no math. I'm going to stop recording now before I get fired too much. Okay, hold on.